Good day, everyone. I hope everybody's having an enjoyable conference. This session right here is called Navigating the 5G Edge, Xhaul and Slicing and MEC. Oh my! We'll be talking about all the different kind of wild and woolly things that are going to happen at the very edge of the 5G network, how important those things are, and how to navigate that situation. I'm Sam Lyle. I'm the Director of Business Development with Ribbon Communications, and I'll be joined later on in this session by my colleague, Francois Caron. So let's get started. First of all, a little bit about Ribbon Communications. In case you don't know, we are a global provider of both real-time communications solutions like voice solutions and IP and optical networking solutions where we serve service providers, enterprises, and critical infrastructure providers around the world. We are publicly traded on the NASDAQ under the stock symbol Ribbon, and we're making very significant investments in many aspects associated with 5G, both in the transport, IP, and optical technologies, and also in edge computing. So let's start off. The 5G edge is a very wild place, especially for transport and computing applications. There are many unique challenges that are emerging with 5G. There's many different types of ways to split the radio access network to achieve densification. There's the fact that 5G is not just going to come on the scenes and replace 4G, and there's going to be 5G and 4G coexistence. There's technical requirements like the distribution of synchronization. And there's also some interesting business problems to be solved. There's a whole host of emerging, actually sort of yet to be invented services that everybody's kind of got their eye on for making the business case for 5G, slicing services, and enterprise value-added applications. And finally, there's some emerging business models as we start to see the hyperscale companies like the Googles and the Microsofts of the world start to move into this space. How are mobile operators and telecom companies going to coexist with these different hyperscalers? So very unique challenges at the edge of the 5G network. And to make matters worse, there's a host of traditional challenges that have always existed at the edge. There's extreme cost sensitivity. There's a need for simplicity to achieve volume deployment. There's always the problem of fiber availability and fiber consumption. And finally, a lot of the service differentiation that occurs at the edge. So if you're going to differentiate yourself as an operator, how are you going to treat the edge differently so you can achieve that differentiation? So in particular, we'll be talking about a host of new transport network needs and maybe ways to solve them, and new edge computing needs and ways to solve them. So today's topics, there'll be three of them. There'll be Xhaul in edge transport, slicing in edge transport, and then my colleague, Francois Caron, will talk about edge computing. So let's start off by talking about transport at the edge with Xhaul. Now, as we all know, for 5G, there's going to be a need to really densify the radios because people are going to be moving to millimeter wave with shorter distance, achieving greater coverage. And that densification, and to achieve economics with densification, leads to a number of different split options in the radio access network, which in turn lead to a variety of transport network needs. Splitting and actually opening up the RAN and making the RAN a multi-vendor environment really improves the economics and improves the overall service performance because you're able to centralize the BBU components and share that cost among many, many radios. You're able to push the radios closer to the user. And in addition, there's sort of software-defined distributed unit and centralized unit. The components of the BBU now enable a lot of flexibility in how those BBU components are deployed. So splitting and opening the RAN introduces this complicated concept known as Xhaul. Xhaul is sort of short for front haul or mid haul or back haul. We're doing it all kind of together. As this picture shows here, there's many different ways, both for 4G and for 5G, to split the radio access network. We used to, splitting the atom used to be hard. Splitting the radio access network used to be hard, but now this is, something that people are going to do. And what you'll see here is there's a mix of things called front haul, the radio connected to the DU. There's mid haul, the DU connected to the CU. And there's backhaul, sometimes which is from the CU, back to the core. And what you can see from this picture is, if you think about this as a transport problem, many of these different RAN splits are actually going to coexist over the same fiber footprint, especially if you are a mobile operator who's doing, your own transport, or if you are a wholesale backhaul provider or transport provider providing sort of neutral host backhaul. You're going to have to deal with all these splits sort of in a single transport environment, both the latency sensitive front haul pieces of things and this overlapping front haul, mid haul, backhaul. It is kind of a jungle, but it can be navigated. And when you serve these applications, that transport network has to deliver fiber relief and aggregation economics and be really good at it in this mixed world. And not only in this mixed Xhaul world, but it's actually a mixed multi-vendor world as well. Again, especially if you are a wholesale or a neutral host kind of operator. So lots of different needs for Xhaul Transport. And, in the early days, there was fronthaul when people started doing CRAN or centralized RAN deployments, where the radio unit was split from the baseband. And a lot of people used dark fiber. And they could use dark fiber, sort of if one could get enough dark fiber. And if one could get dark fiber, you had to get it on time. Sometimes it takes a while to get fiber. And sometimes it's expensive, so if you can afford it. And that was pretty much the only solution that's out there. A little bit of DWDM is used, but it's largely a dark fiber kind of play. So again, if you're a wholesaler or a neutral host kind of transport operator, not a really good lit services opportunity, at least in the world of 4G. With 5G coming along with Xhaul, it's going to require some sort of active transport solution. Can't just be dark fiber, or else the dark fiber requirements are just gonna explode exponentially, and the cost of that solution will explode exponentially, or you'll have to wait an awful long time to get enough fiber out there. So both for 5G radio densification with a lot more traffic, 4G and 5G coexistence with supporting both of those generations at the same time, it's really going to make the fiber requirements explode, and I'll show you some pictures of that. So lots of things, fortunately, kind of in the Xhaul transport requirements and toolkit. You're going to need CPRI or over Ethernet. That's radio over Ethernet. It's an IEEE standard. And that's for 4G, and eCPRI transport for 5G, both over Ethernet, with a technology called TSN, that's time-sensitive networking, to make sure traffic is prioritized accordingly, to converge both 4G and 5G on the same transport network. Bidirectional optics are going to be a really important tool to sort of double the fiber pair gain. There's some great economics associated with that. A combination of active and passive WDM solutions to hit the cost points. WDM by itself isn't going to be sufficient. Ethernet by itself isn't going to be sufficient. It's a combination of Ethernet and WDM that you're going to need to use, and a combination of both active and passive solutions to hit all the different cost points. There's some unique things that one can do with daisy chaining, is maybe one fiber route picks up traffic from multiple towers. You want to backhaul that all or Xhaul that all along the same fiber route. So daisy chaining is going to be important. Synchronization, tighter synchronization standards, Class C and Class D. 25 gig interfaces to the radio units, and finally interoperability with multi-vendor RAN. So there's lots of requirements, but there's lots of emerging technologies then in your toolkit to meet those requirements. So let's talk about improving front haul economics, in particular with transport. On the left would be sort of a traditional dark fiber solution. I'm just showing a simple example to illustrate the point here. There's 4 remote radio sites. If each of those 4 sites has 3 sectors, you would need traditionally 2 fibers for each of the 3 sectors. If you're supporting 4G and 5G, that would be times 2 again, times 4 radio sites. That would be 12 fibers per radio site, or 48 fibers altogether. That's an awful lot of fibers, and it's an awful lot of ports on the poor DU and BBU that's trying to terminate all that traffic. With Xhaul Transport solutions versus just dark fiber, you can employ bidirectional optics. You can employ WDM technologies. You can transport both CPRI using radio over Ethernet and eCPRI traffic on the same general purpose Ethernet infrastructure. And you can really reduce the amount of fibers that are required, the amount of time to deliver service. You can get that down to 1 fiber per radio site. And you can actually achieve about a 6-to-1 DU to BBU port consolidation ratio. So if there's, let's say 48 ports in the radio sites, you can get that down to a much smaller number of ports there in your DU, BBU, depending upon the mix of CPRI and eCPRI traffic. So you can see that implementing some sort of transport solution can really, really reduce the quantity of fiber that's needed in this portion of the network. I mentioned earlier the idea of needing both active and passive solutions. This is the previous slide here. I'll go back. It kind of implied an active solution on both ends, and that's probably going to be important when those radio units are at some of the larger sites. When you get into some small radio units at smaller sites, people talk about small cells, and that people talk about street furniture. So basically, street furniture is anything that's out there, on the street, that's tall and stationary. So, if you're an extremely tall person and you don't move very much, you might have somebody come along and try to deploy a radio on your head to make money. But anyway, small cells and street furniture, those are very space and power sensitive locations. So it makes an awful lot of sense to deploy a passive transport solution at those locations. And the way you do this is basically just passive WDM filters that go there. They don't require any power. And you put DWDM optics directly in the radio units and put all the active front haul gateway type of equipment at the aggregation or hub sites. One of the neat technologies that's becoming available is these tunable WDM optics. Now, tunable optics have been around for an awful long time, and you provision it from a control center or something like this. But in this type of application where you want to do this in very mass quantities, it's much simpler just to put the optic in, have it connected to the WDM filter, and the optic itself, because it can sense light coming off that filter, the optic itself can figure out how to tune itself, and it's completely self-tuning. And that's a very significant operational expense, especially in cases where you're going to be putting radios out to lots and lots and lots of small cell locations. So this will be an important way to do that fiber relief that we talked about earlier for smaller cells and street furniture type of applications. The other thing I alluded to earlier was the idea of the single fiber route that runs past multiple cell sites, and the idea of having even more fiber relief and economics by daisy chaining those cell sites together. So one solution to do this involves both the Ethernet capabilities and WDM capabilities again, where you start with the tower on the far left-hand side of that picture, and there's CPRI traffic, radio Ethernet, and eCPRI traffic, and you pick that up, and there's a 100 gig optic that starts to bring that traffic back. When you hit the next site, you don't want to run all that traffic through another active set of electronics. You want to bypass it at the WDM layer every time it goes up to the DU and BBU location. So if you have some WDM in there, basically you're not creating a bunch of packet hops for all these different these different cell towers. You can bypass that traffic at intermediate locations, and the total bandwidth on any link adds up over time. You have 100 gig at the remote site, then 200 gig, then 300 gig, and 400 gig. Using this kind of approach, you only use 100 gig optics, which are much cheaper than using, say, a 400 gig chain all along the link, which is probably overkill for any one given site. So this Xhaul daisy chain will be a very important part of people's toolkit in solving this kind of transport problem. So that's kind of a quick overview of the Xhaul Edge. In summary, Xhaul Transport controls costs, and if you're a wholesaler or neutral host kind of backhaul provider, this is going to enable you a nice revenue opportunity versus simply selling dark fiber, which really folks don't like to do. So the Xhaul Transport will dramatically reduce the fiber requirements. CPRI, which is transported by radio over Ethernet, and eCPRI with TSN can be used to converge both 4G and 5G on the same Ethernet-based transport infrastructure. And then you can implement the WDM layer. You have bidirectional optics to again double your fiber pair gain. We talked about combining active and passive solutions to hit the cost points. We talked about daisy chaining. Didn't have time today to talk about synchronization, but delivering a higher quality of the synchronization all the way to the radio site is going to be very important to optimize 5G performance. And it's not always possible just to deliver that synchronization with a GPS kind of system. So the network is going to have to be involved to a much greater degree than it was previously. Okay, so that's our topic on Xhaul. Let's shift gears a little bit. I'll go forward here. Shift gears a little bit and talk about transport at the edge, another transport topic. This is the topic of network slicing. Network slicing is going to be a critical topic for 5G in order to deliver differentiated services. And there has been a little bit of what I perceive to be confusion in the industry about the nature of a slice. Sometimes folks will say, well, we've had VPNs around for years. Slice is just a VPN. And kind of yes and no. A VPN does a really good job of creating a closed user group that operates over shared resources where folks' traffic doesn't mix with each other. That would be bad. But the resources underneath those VPNs are still shared, and there's not a tremendous degree of isolation between VPNs. So if there's some sort of congestion activity on one VPN, the other VPN is actually going to be affected to some degree, and that's why the service level agreements for these VPN services are typically statistical in nature. And there's a higher degree of slicing that can be provided. If you look at I like the GSMA's definition of a network slice. They call it a dedicated network on a common platform, which is implying a much higher degree of isolation than one would normally get with a VPN. So the resources are isolated. The different slices will deliver performance and different characteristics as if they were separate networks. They're separately managed. You can have different network behaviors, and actually you can have much more stringent service level agreements because you're getting much more stringent levels of isolation between the two slices. To implement network slicing for 5G, it's not just a RAN issue, it's not just a core issue, it's a RAN, core, and transport issue to interconnect the RAN and the core. All those three things kind of have to work together. I'll be talking a little bit more about ways to do transport network slicing. So there's a couple different ways that folks talk about slicing in the transport network. On the left, you see there's a thing called soft slicing that sometimes folks talk about. And these are what I would characterize as conventional 4G backhaul VPNs. You get great stat muxing efficiency, thumbs up for that, but you get that statistical SLA, which may or may not be good enough for some of these very sensitive tenants or some very, very sensitive 5G applications. Kind of the opposite of soft slicing is, of course, hard slicing. And for hard slicing, think private lines or wavelengths, and boy, you get bulletproof isolation of resources, thumbs up, but utilization is not necessarily so good. That can be very underutilized. Now, your customer may be willing to pay for that, but still you're getting underutilization, and perhaps one can do better. So there's this idea then of a hybrid slice, which actually combines the best of both worlds. A hybrid slice is basically a VPN that runs inside a hard pipe, and what we recommend is using a technology called FlexE to provide that hard pipe. So you get the kind of the best of both worlds. You get the guaranteed isolation that a FlexE hard pipe gives you. FlexE is basically a TDM slice structure that exists inside an Ethernet pipe. So it's kind of different, but very robust. And not just that FlexE hard pipe, but also the VPNs, traditional MPLS VPNs that can go inside the hard pipes, so you still get stat muxing efficiency. So you get the best of both worlds. You can isolate your tenants from one another, give one tenant this hard pipe, give another tenant that hard pipe, and then that tenant can have different VPNs for the different sub-slices that they're interested in and get an awful lot of stat muxing efficiency out of the solution. So you get the best of both worlds. Because hybrid slicing leverages this combination of VPNs inside hard pipes, you get very superior multi-tenant isolation. This picture on the upper right here shows just a simple example. You got a couple hard pipes, let's say hard pipe number 1. That's consumer traffic. That's, schmucks like me browsing on their smartphone. So you want to oversubscribe the daylights out of that traffic so you can make your economics work. And if there's some congestion on it, okay, my stupid traffic is going to be affected, but I'm just browsing. The internet doesn't really matter. The important point is if there's congestion on hard pipe number 1, hard pipe number 2, which is your government tenant or your financial tenant, their traffic is untouched because they've got mission critical stuff going on. They get stuff that really matters. They're not looking at Facebook. They've got their mission critical VPNs inside hard pipe number 2. And any congestion that's occurring in pipe number 1, it's not going to touch pipe number 2 at all. And the drawing on the lower right, if your whole transport network is built around a VPN concept only, a soft slicing capability, some of these mission critical VPNs are going to be compromised by congestion from schmucks like me unless you whoppingly over-engineer the network, in which case there's a lot of empty seats on that bus and you're going to pay for that. That's not good. So with hybrid slicing, the flexi hard pipes can be in different granularities. That gives you a lot of control over how you use that bandwidth. It could be in by 5 gig granularity and by 25 gig granularity. You get great multi-tenant isolation, stat muxing inside, and you can move those pipes dynamically for on-demand types of consumption models. And it's really essential to implement something like this to kind of complete the 5G network slicing picture between RAN and transport and core. Isolated services, this is a well-known fact in the marketplace today, isolated services command a premium. This is an example from a US Tier 1 telco and their tariffed offering and how they price. In this case, it's enterprise services, but it illustrates the point. This isolated service is sold at for the same amount of bandwidth. The isolated service is sold at a terrific premium over even the highest quality of layer 2 VPN service that they offer. And there are people out there who want that and willing to pay for that. So it's a premium service that you can offer. Government sector is famous for wanting these types of circuits. Financial, healthcare, critical infrastructure sectors all want that kind of premium isolation. And for consumers as well, there is a market for this sort of thing. And this is, I don't have teenagers anymore, but people who like gaming. There are a lot of people really into gaming, really moving toward cloud gaming. There's a bunch of market surveys that have been done on this. This just happens to be one of them. But a significant fraction of ardent gamers will pay 50% more for a higher performing service. Lots of gamers would switch providers to get a better gaming experience. Lots of gamers would pay for a bundle of cloud gaming plus 5G connectivity, so you can kind of move up the value chain there. And the vast majority of people who play cloud gaming, you know what? I didn't think they'd really play on mobile devices, but they will. Survey after survey shows that folks will play on mobile devices if they could get sufficient performance. So if you're a mobile operator, you could use one of these premium slices to offer cloud gaming, bundle that with your 5G subscription and carry that over a high performance gaming slice. This is just an example of what you can do. I mentioned flexible consumption models. End users generally want connectivity only when and where they want it. Hard and hybrid slicing can differentiate your offer with a flexible consumption model where you can set up and tear down those slices in bulk dynamically. That's something that comes along with this that can also differentiate your offering. And finally, you can actually offer slices inside slices. So if you're a mobile operator and you're looking at being a retail mobile operator plus doing a little bit of wholesale retail mobile operating, you can actually create slices for different MVNO tenants. And again, these hard pipes are going to offer complete isolation and a differentiated SLA to that MVNO tenant. But they can set up VPN services inside their hard pipe and get the kind of stat muxing and sub splices that they want to do. So you can actually have a case where there's slices inside slices. So So that's a lot to think about. So in summary, hybrid slicing can create a differentiated offering. It completes the complete 5G slicing service, has to transcend the RAN, the core, and the transport network. These hybrid slices, which are VPNs and hard pipes, guarantee multi-tenant isolation, and there's a whole class of verticals that are willing to pay for that. So with that, those are our transport topics for this session. Next, I will turn it over to my colleague, Francois Caron, who will talk about mobile edge computing. Hey, Francois.
Thanks, Sam. I appreciate you giving me the opportunity to talk about edge computing today. Hi, I'm Francois Caron, Director of Product Management here at Ribbon. My team and I are responsible for Ribbon's MEC solution. I'd like to start off by saying that edge compute is one of the reasons 5G is going to be so much more than 4G. A lot of the use cases that have been discussed aren't new. IoT has been around since the 2G, 3G era. Mobile internet is something that has started and is continued to being very much used since the 3G and 4G networks. So really, what's changed? Well, from a 5G perspective, there are three things, right? First one is speed. With 5G, you're going to have the ability to stream 4K video in real time. Next, it's connectivity density. The number of devices in a square kilometer are going to reach roughly 1 million devices. So from a smart city perspective, if you wanted to connect all your lampposts, all your traffic lights, and a ton of cameras, it's something you can entertain. Finally, there's also that always connected, super reliable, low latency link. So if you think about more futuristic applications like self-driving car and remote surgeries, 5G makes that possible. And then the mix and match of these three different pillars are going to enable all sorts of new or revamped use cases. Think about industry automation, for example. That said, 5G by itself is a good start. It has a fast connection speed, super reliable connectivity, so we can start dreaming about all these ideas, but really to make that come to life, the underlying network. Think about the how do I get packets processed? Where do I get packets processed? Those are two key aspects that we also need to combine with 5G to really bring everything to life. Sam touched on the importance of slicing, really isolating the different types and different classes of traffic from one another. The point I want to make here is that's good, but the location where all those packets get processed is equally important. Let's consider a couple of examples as to why edge computing and 5G are important. Think about gaming, right? You want to play your favorite game, so you start up your app, you're connected over 5G. If there is no edge compute, let's say you're in Seattle, and that instance that's provided to you is somewhere in Atlanta, you're going to have a blazing fast connection to the tower, but then you still have to go across the country to get your packets processed. And that's going to hinder your experience because the latency isn't coming from the wireless aspect, it's coming from the fact that the packets need to go across the country. Now think about the same setup with the same user in the same tower. But if we pushed that compute instance somewhere that is much closer to that user, and let's call that edge computing in this instance, then your quality of service and the quality of experience for that user is going to be so much more. And really, we're talking about the same network here, same user, same tower, same kind of connection. But by pushing the compute towards the user, you get a lot less overall latency, and that translates directly into better quality of experience. Other concepts, aside from latency, also become important. Think about user behavior. Right? This is from the Ericsson Mobility Report from last summer. Since 2019, mobile traffic has been overly video related, right? We're talking low 60%. In a couple of years, Ericsson's forecasting that the amount of traffic is going to go up, but the percentage of video content is also going to go up towards the mid 70% range. What that means is when you go back to the importance of edge computing in your network, think about utilization, right? You're an event planner spinning up a content delivery network so you can record live the content and then stream that to paying users is really interesting. But if the carrier you're working with is going to charge you on a bandwidth usage, you're going to be consuming a lot of core bandwidth. Wouldn't it make more sense if you spun up multiple CDNs, all of them closer to the users where it matters, to minimize network congestion? So really you're offloading a lot of the core bandwidth usage towards the users where it makes a lot more sense. Other things like content adaptation could also be done towards the edge instead of the core network. So overall, everybody's going to benefit from an improved quality of experience, and you're going to unclog the carrier's network for other applications that would need to go towards the core. Okay? So basically, consider the fact that you're going to have multiple edges. It might be on-prem, it might be towards a tower, or then at some point of aggregation level, whether it's near the tower or near the core or the core itself. So if you're an app developer, if you have an idea, it's important to figure out where your compute is required and why. It might be factory automation. You want to have everything on-prem, you just don't want to have to connect wires to all your devices. If it's the self-driving car example, well, if you're going to have to make decisions in a split second, keeping that compute near the tower to ensure that the responses back to the car happen very quickly is going to be very important. But if we go back to our video example and the CDN, well, it might not be tremendously important to have a CDN instance at every tower in the network, but at some form of edge or near edge aggregation might make a lot more sense simply to unclog the core carrier network. Before I hand things over back to Sam, there are two other aspects that relate to edge computing that I think it's important to talk about. First and foremost, I think the hardware selection is something that I want to pause here and talk about. As you build out the multiple edges in the network, you're going to have thousands of mini clouds. Let's call them edge compute clouds. Figuring out the types of applications and their need is going to be critical to manage the cost of the build out. Specialized hardware like GPUs are frequently used for applications like facial recognition, tracking cars, transcoding, or if you want to do any kind of machine learning or edge analytics. It's important to understand where those apps will live, who's going to use them, so you can optimize how you build out your network and how much it's going to cost you to build out your network. So making those specialized hardware available to your app developer community is going to be an important factor. The last thing I think is important to talk about has to do with edge analytics. You're looking at thousands of sites, tens of thousands, millions of devices, and everybody needs to do their part so that the network isn't chaotic. Individual users or individual apps might not understand exactly what's going on. What they will recognize is poor quality of experience. It's lagging, it's not responding, the decisions are coming late, something's off. Having some form of analytical ability to understand and look at what's going on in the network so that you can recognize that things are going sideways and then come up with a plan or at least information that would help applications make better decisions so that the network stays well behaved is very important. Think about a congestion heat map, for instance. One sector might become very popular for whatever reason. There's an event, right? A Super Bowl, there's a party, there's something going on, and there are more users or an abnormal number of users in a specific location. From an analytical perspective, you might use that information and then provide insight back to the application so that they can adapt their behavior. If we go back to that CDN example, one example would be provide lower resolution video so that we can write out the current situation and unclog that slice of the wireless network so that everybody still has a good quality of experience. So analytics at the edge is going to be one of the key components that is going to make 5G and edge computing the success it's planned out to be. With that, I'm going to hand it over back to Sam. Thanks for your time.
Well, thank you, Francois. Boy, mobile edge computing is a fascinating topic. So I know we've thrown a lot of things at you in today's session. I hope you've enjoyed it. We've talked about 3 ways to navigate the wild and woolly 5G edge. We've talked about Xhaul Transport and how important that is going to be to conserve fiber and realize your economics. And how if you're a wholesaler or neutral host kind of operator, this is a way that you can offer a lit service to a mobile operator versus just selling dark fiber. We've talked about 4G, 5G evolution, coexistence, and multiple split models and the requirements and solutions available for that. Second thing we touched on was hybrid, hard and soft slicing in the transport network, and how you can provide a combination of hard slices and VPNs to offer a premium type of service, high value slices to high value clients, and completely isolated multi-tenant networks. And finally, Francois talked today about how edge computing enables the very high value software applications, in particular by coupling together analytics to optimize the application performance under dynamic and changing network conditions. And actually, this is another topic, but how to unify actually the orchestration that goes on between the transport network and the MEC environment for the most superior kind of performance. So thank you for joining us today. As always, we are available for questions. Again, I am Sam Lyle and my colleague Francois Caron. If you have questions, please send us an email, and we look forward to hopefully seeing you in person at the next CCA event. Thank you very much.